Hi everyone, welcome to yet another talk on AI/ML for the product leaders. In today's talk, we'll talk about the steps that we need to follow when we move an idea from ideation phase to the implementation stage. In other words, when we work on POC and when the transition of the same has to be done for production, what are the challenges we follow and why eventually it becomes inevitable for not to go for the inference engine. Today's talk is primarily focused on using the self hosting models, where using the license is not an option and we need to go ahead with our own implementation at a production scale level. We'll talk about the same more in detail. So let's hop on to the slides we'll be covering today. So we'll be starting with the high level understanding of what exactly we are talking about today. We'll be talking about scaling machine learning models in production. We'll talk about how we see the different parameters that works well when we are trying to come up with a proof of concept, and what are the parameters that becomes very critical and the driving force for us to switch to VLLM or any other inference engine. Just to reiterate, this is more confined to an open source model or the implementation that the companies want to do within their guardrails and within the proprietary. So let's see. The discussion we have broken down into the three phases. To start with, phase one that talks about the POC, followed by the MVP, where we'll be talking about the tipping point, the factors that makes us to do the pivot, and eventually we'll be talking about the production stage that covers the phase three of our talk today. So the leadership value that or the takeaway for the leadership would be that a product leader would be able to demonstrate the execution maturity and also will get the production readiness knowledge through strategic tooling selection and scaling approaches. In other words, a person would be able to understand wherein the limitation comes in and where we touch the ceiling at a POC phase and what are the tools we need to select and what are the criteria we need to evaluate when we move it to production stage. So when we talk about the machine learning deployment lifecycle, so the journey starts from POC to production, and the practical evaluation path, if we see, as we've just discussed, has the three phases. So in the POC phase, we are able to do the rapid prototyping. We can simply try deploying a simple API at the Flask endpoint, and we can demonstrate the feasibility of our ideation. That we can pitch in like what idea we have thought about is something that's feasible functionally. However, the non-functional requirements kicks in when we go to another stage that's called the phase 2, where we are ready with the MVP and we can foresee the issues that might bring in when we talk about scaling the same product into the production. And we talk about the terms latency, throughput, or the memory utilization of our infrastructure. So the phase 3 is something where the throughput and how we can leverage the product, how we can evaluate the operational cost and how the cost that the deployment will incur is something that can be justifiable in against the return of investment that you are projecting here. So before we dig into the tipping point and why using LLM, VLLM or the inference engine is must, we need to understand what are the limitations or the boundaries that comes in with the classical implementation of LLM against the Flask API. We'll just have an overlook on at a high point, and we'll talk about the same in detail in the forthcoming slides. So particularly here we are talking about what LLM gives us out of the box. LLM, as we all understand, works on the terms of tokens. However, there is no understanding for us to know what exactly happens behind the scene, how the concurrent requests are being addressed, and how the GPU memory allocation has been given so that the operational cost that comes with the huge traffic and deploying in the infrastructure that comes in. So we don't know the request lifecycle knowledge. We don't have that understanding how the request is once it's being given from the end user, how it is being processed, and how the latency is being addressed, and the other factor as well. It's more like a black box for us. Now, if you talk about how it's feasible in current situation, OpenAI or cloud, they already have their own inference engine, but those are proprietary. So those are something not exposed to the end users. API simply exposes the tokens that we feed in, and we get the output in terms of the output tokens. But we don't have the clear understanding of the GPU execution. This is more like a SaaS based, so it's falling outside our context. However, the problem or the challenges kicks in when we talk about the self-hosted models where we cannot move the data outside the system. We need to be within the enterprise guardrails, and we have security is one of the primary aspect for us, and wherein we can't afford to go for the licensing version as well. What's the solution? The solution kicks in by using or by developing our own inference engine. Now, since VLLM is something that is an initiative from Red Hat, this is something that can be leveraged by any company as such, and we'll be taking the VLLM as a reference here. So what exactly VLLM or any other inference engine brings in? Particularly for VLLM, it brings in the three aspects that addresses the and makes it feasible for deploying the machine learning model in production at a scale. That's the KV caching, or in simple term, a caching mechanism for the pre-processed queries. That it's something analogous to any standard caching mechanism. Based on the cache hit, you can easily address the latency. Followed by the continuous batching for the similar queries, and the GPU allocation. That is something that brings in the idea of utilizing the memory to its best, and hence overall addresses the operational cost that comes with the computation. Continuous batching in caching addresses the issue with the throughput, and also thus makes it possible for the concurrent processing of the request, and is something totally within the context of the company who is developing the inference engine for their self-hosted models. Now, where all the Flask is good, phase 2. And the phase 2 talks about the limitation that pitches in once we are done with the basic evaluation of our idea. Flask capabilities fall into the factors that it's quite easy to set up, it's lightweight, rapidly we can do the prototyping by deploying simple API application and confirm and bind the stakeholders from the perspective of an idea that is something feasible. However, the architectural transition is required. It's not the limitation from the implementation perspective of Flask. However, it's the architecture challenges that kicks in. What are those? Primarily the performance bottleneck, because Flask model works on a single-threaded model, and it struggles when we have concurrent requests coming in, and machine learning has model deployed has to infer the load in parallel, and hence increases the latency and make it inevitable not to drop the forthcoming requests. Memory management and operation complexity, because we don't have in the privilege of using the or defining the memory management, and also how we can reduce the operational cost associated. And that is something that kicks in when we need to scale our product for the real time for production usage. So this is something we say at an ideation stage. At a POC we are able to do everything, but that doesn't get transition when we move to production. And seeing these challenges, we have to do a early decision on whether to go ahead with Inference Engine or we are good not to go ahead with the pilot itself. This is something very critical from product manager or the leadership perspective, because we need to foresee the return of investment by taking into consideration the operational or the infrastructure cost as well. So this is something will help us to project the metrics well. And based on the metrics we defined as the acceptance criteria for a POC should be good, but is not the guarantee for the same to work well in production. So we need to consider these aspects as well. So considering from here for that, let's say it worked well for the POC and we are getting go ahead from the management to do the same for production. So our infrastructure get into the queue shift. As we said, it addresses the latency, the memory issues, and concurrency issues. When we move from Flask to Inference Engine, let's break it down further. The increased latency here refer to we get slower model inference and request gets queued up because the Flask follows the single-threaded model, followed by memory issues because we get into garbage collection overhead, and also we don't have control on the memory management, and hence we hit the out of memory errors. And concurrent issues also suffer because we have to drop the request based on the thread contention, and eventually throughput also drops. So all these are being addressed by VLLM. So using VLLM we get a better specialized serving framework so that we can address the issue of throughput, latency, and operation cost optimization as well. So page attention is something that is the concept behind that helps for or that defines how the memory has been allocated for the GPU using VLLM. And continuous batching something that makes the subsequent calls to get joined with the existing batches and ensure that GPU is utilized to its maximum capability. And thus this helps us to handle more concurrent requests and eventually improves the throughput for the system. If we break down the benefits or the cost benefit analysis for the migration when we move from VLLM to from Flask to VLLM, is development effort are on the lower end for VLLM. It means for VLLM we need more development effort, but Flask wins here for the development perspective. Same is the infrastructure cost is less for Flask but more for VLLM. However, that is still within our control to use that or improvise the same for addressing the operational cost. Performance gains is something where VLLM beats definitely Flask because it turns out to be like 24 times higher throughput. And also the maintenance is something that get reduced. However, it's not as low as for this Flask, but that can be understood because this has to be production ready. So for the leaderships, the takeaway is like assessment could be done easily with the Flask API, but moving from migration to optimization, we eventually need to go for the Inference Engine only. That is something inevitable. So the initial development done by Flask, evaluation stage help us to recognize when we need to move to VLLM or Inference Engine, and we can opt for VLLM or Racer as one of the provisions we have. So this is all we had to cover for today. I hope we had a good understanding of this and a good takeaway for the leadership. Thank you.